Good morning, everyone. I've never really spoken to the internet before, so this is a slightly surreal experience. I'm sat here just talking to my laptop all on my own. I guess it makes more sense than just sitting here talking to myself, but it does feel a little bit odd. But the reason for doing this is because I have all these presentations knocking about my hard drive, and you give them once to whatever audience they're intended for, and then they never see the light of day again. And I thought, well, rather than just having all of this stuff languishing on my laptop, not really doing very much, why not start to put this out there for other people to look at? Hopefully there'll be a few of you who find some of this stuff interesting. So if this talk goes well, if this is sort of a provisional test, if you like, if this all goes well and is well received, I see no reason why we couldn't do this more regularly with other presentations I've put together in the future. So if you like what we're about to do let me know, and I'll see what I can do about getting a few more things like this put together. So this is a presentation that I gave a few weeks ago at the Lyme Regis Fossil Festival. Some of you may have attended. This is a festival that takes place every year in Lyme Regis, which of course is famous for being a historically important site for paleontology. It's where some of the first marine reptiles were found. It's where Mary Anning sort of was doing all of her work. So I was asked to give this talk at the Fossil Festival, in addition to a gallery which I put on, which is called Paleoart Works. And this was sort of for me, the closing event of the festival. I gave this talk at sort of 4 o'clock on the Sunday, last day of the festival, and it's fairly well received. So I thought, hey, let's see if anyone else would want to have a listen to it. So this presentation is all about, it's a sort of a really basic, very general overview on Paleoart, sort of what it is and how we go about doing it. This is the first time I've ever really spoken about Paleoart to the public. Not ordinarily when I give talks, it's more as a scientist. This is kind of the first time I've really spoken as an artist. Hopefully there'll be some stuff in here which will be of interest. As I say, I kind of try to cover the whole thing, and obviously for that reason it can't be quite as detailed as I might like, but it should give you a little bit of an idea about how Paleoart sort of works and how we put some of these images together. So we'll get cracking then. What is Paleoart, and sort of why do we do it? Well, I think that the simple reason is because we're fascinated by the fossil animals that we discover, and I think a very obvious question for us is, what do these things look like when they were alive? Okay, all we're finding are the hard parts of these animals. We're finding is their skeletons, and we find modern animals fascinating, in terms of their appearance and what they do and how they work. And I think that's a very obvious question to ask about fossil animals. And of course, these animals are long dead. There's no way we're ever going to bring these things back to life. These things are millions of years old. They're completely gone. Most of them are completely extinct. So, the only way we can really bring these animals back is through artwork. By producing pictures or sculptures, or creating movies of them and this kind of thing. So I think this is where Paleoart comes from. I think we're just inherently fascinated by fossil creatures and their life appearance, and so we've kind of generated this industry of Paleoart, where we take the science of these animals and we kind of put it through a filter of what we know about modern animals, and sort of combine the sort of modern natural history art with the paleontological science, and how we come together at the end with Paleoart. Sort of the best attempts we can at any one time to bring these animals back to life, in terms of their basic appearance. And so, as I say, I think it's mainly just because we're really fascinated by these animals. That's why we do Paleoart. But that's not to say that Paleoart doesn't have any sort of use, and not to say that it's not just simply a case of us drawing these things and creating them in sculpture and sort of in digital formats. We're not just doing that for fun. It's not just sort of an idle exercise carried out by people with too much time on their hands. There is some real use to this, and I think we can actually say that Paleoart has got this kind of long established culture as well. I think there's some there is some real kind of merit to what Paleoartists do, and it kind of should be recognised as a as a sort of worthwhile and useful art form. And so I guess one of the primary uses of Paleoart is its use is its outreach potential. So Paleoart is something that really speaks to audiences at all levels. You think that Paleoart tells us an awful lot about what scientists think of the appearance of the size, of the proportions, of the sort of the environment in which these animals live. Paleoart tells us an awful lot of information without any of us having to read a single word. And that's not to say that we're lazy and we don't want to read, but it's simply that Paleoart communicates to people across, across communication barriers, across normal communication barriers. We can, it doesn't matter what language we speak. It doesn't matter if we can read. We can understand things about animals in deep time without having to actually read anything about them. Paleoart is a terrific outreach tool. It's a very good way of conveying what we think about these animals in a rather short space of time. So this is why I think we see Paleoart across so many different formats and in so many different media. You see Paleoart in children's books. You see it in books written for for adults. You see it in fiction, all this kind of thing. Paleoart is really useful in that way of communicating to so many different people. And this has developed to the point where Paleoart is actually, when we start thinking about it, Paleoart is actually worth millions of pounds or dollars or euros or whatever you want to measure it in. Paleoart is big business. So if we move away from pure outreach and we move away from sort of educating people with Paleoart, we start thinking about how Paleoart is useful, commercially, and we start thinking about things like comic books, so things like Flesh in 2000 AD. We start thinking about movies from the 1925 version of The Lost World, King Kong, Jurassic Park, all this kind of stuff. These are films which cost millions to make. There's millions of investment put into these things, and they make millions of dollars or millions of pounds at the box office. This is all kind of coming from a Paleoart source. Of course, we have documentaries as well, which kind of blurring the line between the commercial and the educational aspects of Paleoart. These are sort of outreach projects which have substantial amounts of investment in them, and of course are expected quite often to make a little bit of money themselves. So we have things like Walking with Dinosaurs, Planet Dinosaurs, this kind of thing. Again, millions of pounds, millions of dollars invested in that. And of course we have a huge toy industry as well. We have, Paleoart has really inspired God knows how much dinosaur merchandise, and it's all out there, and it's all sort of derived from Paleoart. So, when we think about it, as I say, Paleoart is really worth millions and millions of pounds of dollars to people. And maybe it's not too surprising that Paleoart has become this, this big institution that's worth a lot of money, and its outreach is sort of recognised is quite significant. And the reason for this is because Paleoart has been around for a heck of a long time. In fact, I think we could say that Paleoart has been around for as long as paleontology itself has been around. So some of the oldest Paleoart we have is on the screen right now. These are pictures by Professor Gene Hermann. He's a German anatomist. These were pictures that were generated in conversations between Hermann and another very eminent comparative anatomist of that time, Baron George Cuvier. These pictures were never published, at least not until very recently. They were never published, but they were used in discussions between Hermann and Cuvier to sort of try and thrash out ideas about what these newly discovered animals that we now call pterosaurs actually were. So what you're looking at here are the earliest life restorations of an animal that we now know as Pterodactylus. And you can see it's sort of been reconstructed as a sort of a mammal-like thing. Hermann at this point thought that Pterodactylus was a mammal of some kind, and you can see lots of kind of mammalian features on this restoration. You can see it's got very mammalian-like ears, lots of soft tissues on the face. It's got a very mammal-like eye. It's covered in fur, which of course is kind of ironic considering we now know that pterosaurs covered it in some kind of fur-like structure, and it has very mammalian-like external genitalia. And as I say, so this is one of the first bits of Paleoart that we know of. It's over 200 years old. So this goes back to the point where really paleontology was starting to become established as an industry itself. This is, back in the 1800s, the very earliest 1800s, people were still waking up to the idea of things like extinction and of life before man, and you see that Paleoart was right in there. But it's interesting that Paleoart back in the very earliest 1800s was really only an academic activity. There wasn't really much discussion of Paleoart, or it didn't really exist basically outside of this rather narrow academic circle. So as I say, these pictures are never published. It's just using correspondence between two scholars. It wasn't until about the 1820s that Paleoart really entered, the sort of the field of publishing, where it became sort of disseminated more widely between scholars. But it didn't really leave the academic world at this point. It was still something that was used by academics to sort of chuck ideas about and say, sort of, it was just used in discussions for, about extinct animals between themselves. And again, George Cuvier was another kind of key individual in this. So of course, I mentioned Cuvier in discussions of these pictures of Pterodactylus. Well, Cuvier was also one of the first individuals to start publishing what we would now recognise as a sort of standard component of Paleoart, in that he was publishing pictures of fossil skeletons with the muscles, sort of, the inferred musculature reconstructed around them. And you can see one of Cuvier's reconstructions on the screen here. This is an animal called Anoplotherium from the 1820s. And really, what Cuvier was doing was no different to what a lot of us do in the modern day, where we take the skeletons of these things, we try and figure out where the muscles go, and we use these skeletal reconstructions as sort of a foundation for the for more sophisticated paleo artworks later on. And so, as I say, these were being published around 1820, but interestingly, at this point, paleo art was not really, although it was being published, people weren't really talking about it that much. It was almost sort of entered the literature quite sheepishly. It was sort of tucked away in the corner of a manuscript, and no one really talked about it that much, even though it was sort of existing there. No one really sort of dwelt on it. It wasn't a little bit later that paleo art became more established and more recognised. I guess in some senses it became a bit more useful. This sort of really took off about 10 years after Cuvier's Anoplotherium reconstruction was published. With this image here, this is a very famous and significant image in the history of paleo art. This is an image by Henry de la Beche, an English paleontologist and geologist. This was the first ever commercially produced bit of paleo art, and de la Beche actually did this to help finance Mary Anning's fossil funding exploits. Okay, so it's well known that Mary Anning was a rather, she was rather hard up for cash for most of her life. So de la Beche produced this image to try and to sell to academics, to try and help fund some of her, some of her fossil finding exploits. And this isn't just a significant image in terms of its commercial importance. It wasn't just the first time paleo art went on sale. It's also significant for being one of the first ever sort of scenes of extinct life. It sort of reconstructed as it was at the time, rather than just being sort of a a reconstruction showing this is what we think it looks like. This is saying, hey, this is what these animals looked like when they were alive, living within their environment. It's an actual reconstruction of the paleo environment as well as a reconstruction of the extinct animals. There's lots of other reasons why this picture is significant. We don't really have time to go into them all now, but suffice to say that this picture that we call Duria Antiquior, this picture was hugely influential, and it was very, very successful. It was sold across Britain. There were scholars buying it to enrich their lectures on paleontology. When they were talking about marine reptiles, they had this picture up behind them saying, hey, this is what these animals look like. So this picture, as I say, was very influential and very successful. People went on, I guess, slightly more refined versions of the same picture. So this is a picture, a sort of a derivative work from de la Beche's original by an artist called Robert Ferran. This was produced in 1850, and you see it's basically the same picture. And these were reproduced because, as I say, it was so successful and people wanted to keep using it, but maybe they recognised that de la Beche's original wasn't the most sort of, it wasn't quite as technically tight as it could have been. So this is why pictures like this were produced. But of course, the important thing is that by this point we've got lots of artists producing paleo art. We've got sort of people outside of academia being asked to reproduce, being asked to produce paleo artworks. So this is significant. Duria Antiquior is a significant painting in the history of paleo art for lots of reasons. But of course, as I say, by this point, paleo art is still sort of an academic pursuit. Hasn't really moved out of the sort of the universities and out of museums. This changed in the 1850s when paleo art was sort of seized as a public outreach tool. And of course, you all know what I'm going to be talking about here. These are the the very earliest models that were produced of what were then understood to be the life appearance of dinosaurs. They were displayed in Crystal Palace, produced by Benjamin Waterhouse Hawkins, a fantastic natural history artist and sculptor, and produced under the supervision of Sir Richard Owen, of course, a very famous figure in early paleontology. And it was really Hawkins and Owen who really saw the potential use for Paleoart as sort of for public outreach, to reach out to the masses, if you like, and say this is what happened before man appeared. And of course we all know about these famous sculptures displayed in Crystal Palace for the dinosaurs, but it wasn't just dinosaurs that Hawkins made. So we see the famous rhinoceros-like iguanodon in the photograph here, but it wasn't just these dinosaurs. Hawkins also made lots of other different fossil reptiles, including these marine reptiles we see here. He made some Paleozoic reptiles as well. He also produced a whole bunch of fossil mammals, including things like Irish elk and giant ground goats. And he even made a sort of a very simplified model of British geology as was understood at that time. So this was a massive sort of educational event. This was trying to bring not just Paleoart to the masses, but trying to really give people an education in deep time, in all sorts of concepts of it, and things like stratigraphy in terms of dividing life forms up into different eras and into different regions, saying this is what coexisted at certain points. And there are loads and loads of little details. If you go to Crystal Palace, you can see all these little nuances that Hawkins and Owens put into these displays. And there's an awful lot more we could say about it. I don't really have the time now, but there's so much to talk about here. This is when Paleoart really reached, sort of as we would understand it in the modern day, even to the point where people were selling merchandise of these models. So the sort of the dinosaur toy industry that we have now, it really has its birth back in the 1850s. So in association with the Crystal Palace dinosaurs, an entrepreneur, how do you say that? Henry Ward, let's ignore that word, Henry Ward, in collaboration with Hawkins, produced a bunch of scale models of his he produced a bunch of scale models of the Crystal Palace dinosaurs for sale to, at this point they were really for sale to educators and to sort of to teachers and lecturers, again to kind of enrich their talks. But the bottom line is that we had sort of small scale models of these things being sold to people to sort of as merchandise based on the Crystal Palace event. So when we think about it, by the 1850s we had Paleoart established as a research tool, as a tool for public outreach, and it was even being used in a commercial sense. So really, you could say that 170 years ago, Paleoart really existed in the same way that we understand it today. All of the uses that Paleoart has today, they were there 150 years ago. So really, what we're doing is we're just kind of repeating what these early pioneers in Paleoart have done. That's not to say, of course, that Paleoart has not changed over time. And I think if we were to try to sum up the sort of the changing nature of Paleoart in just a simple sentence, I think we would say it's become a lot more rigorous. It's become a lot more scientific. So modern Paleoartists maybe are basing a lot more of their artwork on the paleontological science than our forebears did. We're trying to be more rigorous. We're trying to reconstruct things more accurately. And I think this has got to the point where Paleoartists have actually become a force within the scientific community themselves. Some very famous Paleoartists, people like Greg Paul, have really advanced the understanding of, dinosaur paleobiology, and the artwork was a really kind of instrumental part in that. It was guys like Greg Paul and Robert Backer who started looking at the skeletons of these animals, and in association with their reconstructions, started realizing that the way we're putting the muscles together on these animals are very different from the ways that other famous paleoartists like Charles Knight have been putting the muscles together. They realized that these animals had to be standing in different ways, that they had to be moving in different ways. They were really pushing the science itself, and their artwork was an instrumental part. And this doesn't mean that, of course, we know everything there is to know about fossil animals, and it doesn't. So, it's difficult for us to say where art is necessarily right or wrong. I don't think we're ever going to be able to say that with confidence. but we can definitely say when Paleoart has made the most of the available data. And I think we could say that the best Paleoart is that which is in greatest accordance with the data that is available at the time. And so if we take a good example of this would be reconstructions of feathered theropods like Microraptor. You can see the fossil of Microraptor on the screen here, and you see very clearly the skeleton of this animal. It's complete, it's articulated, and protruding off of the skeleton are very obvious impressions of things like feathers. So from this one single fossil we get an awful lot of information about the life appearance of this animal. So if we're going to do a restoration of this, we need to make sure that the restoration looks like all the data we can get from this single fossil. And so if we have a look at two different restorations of Microraptor here, we see the one on the left. Well, really, okay, you can say what you want about the kind of artistic quality and things of it, but we can certainly say, well, no, this looks nothing like Microraptor as we understand it from the fossil record. The feathers are too short, the proportions are all wrong. It really is, an objectively inaccurate picture of Microraptor. By contrast, the image on the right is far more consistent with what we see in the fossil. The feathers are the right length, the proportions are correct. So we can say that, well, the image on the right is really what the best we can do at the moment for establishing the life appearance of this fossil animal. And this is what paleoartists are really trying to do. This is what the best paleoartists try to do. They try to make sure that their pictures are as good as they can be at any given time. And of course, then the very nature of paleontology is that science progresses and we learn all sorts of new things about even animals that are quite familiar to us. But that's just the nature of science. Paleo artwork does date. That doesn't mean that that it still means that we have to be as accurate as we can at any one given point in time. Okay, so if that's a little bit about the history of paleo art and a little bit about its significance and its sort of accuracy, well, how can we go about producing a bit of paleo art? How do we go about turning a pile of bones, or a pile of fossils, into a life restoration of an animal in its environment? And we don't have time to go through every single method we can use to do this, so we're just going to kind of go over the basics here. But the point I want to make is that really paleo art, it isn't just a case of kind of picking up a pencil and just starting to draw something. There is so much research that goes into a good piece of paleo art that I think that's often not really understood. Particularly sort of among people who aren't really interested in paleontology. There's so much that goes into this that we can be sometimes far more confident about the life appearance of fossil animals than people might imagine. So we're just going to go over some of the basics of this for the next sort of 15-20 minutes or so. And I guess the place we really start off, as you would expect, is with the bare bones of the creatures that we're looking at. So here we have the bones of two Ashdarchiid pterosaurs. These are the pterosaurs that sometimes grow to sort of giraffe-like sizes. They're really, really big animals. What you've got on the left are the fossil bones of Quetzalcoatlus. This is not the big Quetzalcoatlus. This is a smaller species which doesn't have a name yet. We just call it kind of Quetzalcoatlus spur, or Quetzalcoatlus species for the time being. And on the right you have a line drawing of another Ashdarchiid called Gigantopterus. And you can see that neither one of them on their own is complete. There are bits missing. So what we would do here in this instance is we would actually try to kind of amalgamate these two. We would use all available data we can for a single species, but when there are bones missing, we would sort of fill them in with the bones from another close relative. So in this case, Quetzalcoatlus is very near complete, but we might need to use a few bits and pieces from Gigantopterus to give us a complete picture of its skeleton. Once we have a sort of rough idea of the proportions and the sort of the morphology of the bones, we can produce a skeletal reconstruction, which is the kind of thing, as I said, that Cuvier was doing 200 years ago. And we still do this in the modern day. This gives us the basic foundation, the basic blueprints for our paleo artwork. This is kind of tells us the very basics about what this animal looks like. It sort of gives us some things to hang the rest of our picture on. And so from the fossils we go to these basic reconstructions, but then we need to think about how our animals are actually standing. And this is where things get a little bit a little bit more difficult. It's not. I mean, it's not just how animals stand; it's how they carry themselves generally. It's not just how their feet are placed on the floor, but how they carry their necks, how they carry their tails. The sort of the inclination of the back and all this kind of thing. But for some animals, this is pretty obvious. So if we take a sauropod dinosaur here, like Gertie. Okay, this is I'm sure many of you are familiar with Gertie the dinosaur, a very important animal for Paleoartists. It's one of the first dinosaurs to ever be put on screen. Not just so important for Paleoart, but for animation generally. I don't really have time to go into all the stories about Gertie now, but for an animal like Gertie, for a sauropod dinosaur, it's very obvious that it's going to be a quadruped. At least 99% of the time when it's not rearing up to feed on leaves in the trees or something like that. So for some animals, a lot of the details of posture are pretty obvious, but for others, it can be far more controversial. So if we can say that it's quite obvious that sauropods are walking around on 4 feet most of the time, that doesn't necessarily tell us we know everything about the way sauropods stand. So if we have a look at sauropod necks, for instance, there is an ongoing controversy about how these animals carry their necks. So the image at the top left of the screen here, this is a very famous image for anyone interested in Paleoart. This is the walking with dinosaurs, Diplodocus, walking around with their necks held out completely horizontal. And I remember seeing this back when Walking with Dinosaurs came out, and I was quite blown away by this. This was completely different to anything I'd ever seen, any reconstructions I've ever seen of sauropods. I was more used to animals, the sauropods carrying their necks as they are in the bottom right corner of the screen, with the heads and necks held upright, not parallel to the ground in the way the Walking with Dinosaurs ones were. And the reason for this is simply that different people are looking at different bits of evidence and they're saying, well, we think this means that these animals are carrying their necks like this. And as I say, this is the focus of long-running controversies. You can see in the middle of the screen here, this is kind of a pretty standard view of a paleontological conference. It's pretty much how academics thrash out different ideas when there's lots of controversy. And people are still bringing different ideas to this table. So people are looking at the neck biomechanics, they're looking at computer reconstructions of these things, trying to measure arthrological ranges. People are looking at the way modern animals hold their necks. There's a lot of debate, a lot of controversy about how these animals carry their necks. And of course, when it comes to these controversies, paleoartists really just have to do the best they can. They have to weigh up all these different arguments. They have to think about which ones they find most compelling. If they're doing a commission for someone, sometimes it's a case of saying, well, which one would you prefer? When there's kind of equal arguments either side, sometimes you just have to go with whatever the guy who's giving you your paycheck wants to see. So the bottom line is we don't know everything about fossil animal posture. We have to just sort of make the best of what we can from the available science. And of course the reason that we really don't know what's going on with these animals is because there's so much information missing in the fossil record. And a great example of this came courtesy of Mike Taylor of the SV Pal blog. You see on the right hand side of the screen here a nice cute fluffy little giraffe. If you don't like seeing cute little fluffy animals have various bits of them butchered and dissected, look away from the screen now. We're about to chop open this giraffe's neck, have a look at the inside of this little chap's neck, and we can get some sense of what we're actually missing in the fossil record. So you see in the top picture on the screen here, the neck basically as dissected. All the muscles have been taken off there, but you can see the articulated vertebrae, all in with all the cartilage between each of the bones. On the bottom half of the screen, you can see the bones with all of that cartilage removed, and we're missing something like 20% of the cartilage in this animal's neck. Now, of course, what we don't know is how good a model this is for for any fossil animal. Maybe it tells us a lot about the amount of cartilage in the neck of a fossil giraffe, fossil baby giraffe, I should say, but it doesn't tell us much more about the amount of cartilage in, say, a sauropod dinosaur neck. But it serves to demonstrate how much information is missing from from some parts of it serves to demonstrate how much information we were missing when we're only getting hard parts preserved, and of course it demonstrates how limited our abilities to interpret things like posture are from bare bones. Okay, without all of that cartilage in there, there's just no way we can really understand fully how these bones are articulating, how they're working with each other. So as I say, we're simply making the best we can of the available data and the science that is available to us at the time. Now we can call on other parts of the fossil record to give us some idea of the way animals carry themselves, and footprints are a great example of this. Paleontologists will often say, well, trackways don't lie. And the reason for this is because, of course, they record the precise location of the hands and feet of animals when they're walking around. So they're telling us exactly where they were putting their limbs when they were walking. And so this can give us an awful lot of information about how animals are moving about. Now, of course, this isn't a completely sort of straightforward method of interpreting animal posture, because just because an animal, say, has a narrow trackway doesn't necessarily mean that the animal's limbs were being held directly underneath the body or whatever, but it can at least give us some clues as to how the animals are standing and the ways that they're carrying themselves. Trackways can also give us some clues about the soft tissues of animals. So if we take a look at the top right portion of the screen here, we'll see a fairly sort of typical reconstruction of sauropod dinosaur feet. And you can see that every digit has a big claw on there. And that's pretty much what we see in an awful lot of not just sauropod reconstructions, but an awful lot of dinosaur reconstructions. If there's a digit, it has to have a claw on it. At least that's the logic of some artists. When we have a look at sauropod footprints, however, we realise that actually that's really not the case. So you've got some sauropod footprints running up the middle of the screen here. The manus prints, the hand prints, are the ones, the sort of the U-shaped footprints, and the footprints themselves, the sort of the hind limb prints, are the more round footprints that are sort of behind the U-shape or horseshoe-shaped prints in front. And you can see they tell us very different stories about the soft tissues of the hands and feet, the hand and feet of sauropods. So the handprints we see, there's no claw impressions. These animals don't have any sort of nails or claws on most of their digits. The only ones that they might have claws on for some species are sort of the thumb. And you can see a reconstruction of this by Greg Paul, the bottom right-hand portion of the screen there. You see there's a very obvious claw on the thumb, but the rest of the digits don't have any claws or nails on. However, if you look at the back of the foot, there's another interesting part of the soft tissue of these animals. These things don't have a big soft tissue pad on them. So when we look at something like an elephant foot, we might think that's a good analogue for a sauropod, I should say an elephant hand. When we have a look at an elephant hand, we might think that's a good analogue for a sauropod hand, and of course an elephant hand has a big soft tissue pad on it. Well, sauropod hands don't look anything like that. Their hands lack this soft tissue pad, they have this U shape to them. We look at them from the back, they would have a concavity where we might expect there to be a soft tissue pad. So these are rather narrow columnar structures, and they are not anything like the sort of the image that we see at the top right hand portion of the screen. By contrast, the back foot is very, very different. The back foot does have a big soft tissue pad in it, and we know that because it's preserved in the trackways. And likewise, we can see that a number of the digits have claws on them. So, as I say, this can all be gleaned from trackways. Even if we didn't have the skeletons of these animals, we'd be able to make some inference about the soft tissue anatomy and about the sort of life appearance of the hands and feet of these creatures. Of course, there's a lot more to the soft tissues of an animal than just the soft tissues of the feet, and indeed, it's really the soft tissues of the muscles which these are what give us the basic contours for our Paleoart reconstruction. So the skeleton might give us the blueprint, but animals aren't simply sort of bits of skin shrouded over skeleton. Their life appearance approximates the contours of the muscles much more appropriately. So we need to think about how we can reconstruct them. We need to think about how we can reconstruct the muscles of fossil animals accurately. And as you might expect, the way we do this is simply by looking at the closest modern relatives of extinct animals and try to infer details of their musculature from their skeletal anatomy. Sort of by using comparative anatomy, we sort of look at the modern animals and see what we can glean about the muscles of fossil animals, where we can see similarities in their skeletal structure. And of course, because this is science, we don't just try to look at sort of one or two modern animals. Ideally, what we look for is what we call a phylogenetic bracket. These are sort of modern species which bracket an extinct species in sort of an evolutionary sense. So you can see a graphic at the bottom right hand portion of the screen there, which gives you an idea of what I'm talking about here. So we've got two species, living species A and living species B, and we're trying to reconstruct the soft tissues, the musculature of that extinct species. So the way we could do this is we could have a look for soft tissue characteristics, say a muscle, that occurs in both living species. So we say, well, if if living species A and living species B both have this muscle, and they both sort of, we find the osteological correlates for it in the extinct species, but we could say quite confidently that that muscle must have existed there because it has the same anatomy. We see it in its phylogenetic bracketing, in the animals bracketing it in the modern day. So we'd be fairly confident about that. We could very confidently infer that that animal has that muscle. However, if we only see one half of the bracket with a certain muscle, that adds a fair bit of doubt as to whether or not the extinct species has it. It may have had it, it may have not. But because one half of the bracket doesn't have it, we can't really necessarily tell from the fossils when this actually evolved. So it adds a little bit of doubt and uncertainty as to whether the extinct species had it. So this is where we might have to look beyond the phylogenetic bracket and start looking for other evidence for the presence or absence of that particular muscle. And of course we can use that for lots of other types of soft tissue as well, but for mussels it works particularly well because we can kind of tie it quite neatly, very often, to the skeletal structure underneath. But of course there's an awful lot of other stuff that we see in animals which is either quite variably developed across different groups, so it's hard to use that bracketing approach because it doesn't occur in sort of all modern relatives or it doesn't tie very neatly to the skeleton. So things like the pinnae of mammal ears, or things like fur and feathers, these don't always correlate very well across a phylogenetic bracket, and they don't always correlate very well with the underlying skeleton. So how do paleoartists reliably infer their presence in fossil species? Well, the simple answer is that sometimes we just need to be reliant on soft tissue preservation. There's lots of different ways that soft tissues can enter the fossil record. Obviously they're very rare. Most of the time all we get is the hard parts, but on occasion we get sites of exceptional preservation for fossils, and they can tell us an awful lot about the life appearance of a fossil animal. So you can see on the screen here we have various ichthyosaurs, dinosaurs and mammoths, all preserved with different types of soft tissue body outlines, carbon preservation of feathers, and in the case of the mammoth, basically nearly all of the soft tissues of this animal preserved in permafrost, including little bits of fur around the bottom of the limbs there. And so of course paleoartists are very pay a lot of attention to these types of fossils because they tell us a lot about the life appearance of these animals, and we can actually use these, the same bracketing approach, we can use these to help us bracket fossil species more reliably. So we can say, well, when feathers occur in certain types of dinosaur, we can start to bracket off portions of the dinosaur tree where we have feathers occurring and going, well, they must have evolved by at least by this point, and this kind of thing. So these animals are very important, these fossils I should say, are very important for paleoartists. And just to stress the amount of detail we can get for some of these animals, things like hadrosaur mummies. Okay, so hadrosaurs are fairly frequently, I say fairly frequently, more commonly than lots of other types of dinosaur. They occur as mummies. They occur as fossils with lots of soft tissue still draped over the bones. And some of the details on this, is really quite remarkable. So things like hadrosaur hands, we have fully mummified hadrosaur hands, and they tell us a lot about the life appearance of their hands. So again, like with sauropod hands, we don't see nails and claws on them. They just have like a little mitten wrapping over the digits of their body. They don't have individual fingers either. The hands are all sort of bound together into the fingers are all bound together into one structure. And we can have a look at the nature of the skin across some of these hadrosaurs as well. We don't just have skin impressions from one or two parts of the body like we do for lots of other fossil animals. We have them from all over the place. So we actually know how the texture of the skin of these animals changes as we go from one portion of the animal to the other. We see that the scales on the face are kind of smaller than in other parts of the body, and on the side they have these sort of smaller polygonal scales with larger tubercles in the middle, and that the size of these tubercles is quite variable across the flank of the flank of the torso. And as you move on to the tail, they change in nature. The underside of the foot has again a different type of scale morphology. There is all sorts of detail you can get from these animals, even though they're tens of millions of years old. Some of the soft tissue preservation we have is quite extraordinary. And so, yeah, okay, there's always going to be stuff we don't know about the life appearance of these animals, but we can be, again, far more confident than a lot of people would imagine about their soft tissue details. But of course, I guess the real area of uncertainty when it comes to reconstructing fossil animals is the sort of the size of some of their soft tissues. So things like mussels, okay, we might be able to figure out where they go fairly reliably, but how big are they? How much do they bulge? Sort of how much do they distort the contours of these animals with respect to the skeleton that's underneath? And I guess from about the sort of 1970s and 1980s onwards, it became quite fashionable in Paleoart to reconstruct fossil reptiles in particular as rather sort of svelte and gracile creatures that really show the underlying muscle under the skin. So you have reconstructions like this of Eli Kish. These are reconstructions of a couple of tyrannosaurs who, let's face it, they both really look like they need to eat a steak pretty quickly. They look unhealthily thin. And the reason for this is because the muscle reconstruction is far too slender. There's not enough bulk on this animal. Modern animals don't look like this. They have far much more. They have much more substantial musculature anchoring to their skeletons. So this has become known as shrinkwrapping in the modern day. This is where we reconstruct fossil animals, basically showing as much of the skeleton of them as we can. So if you look at the heads of these animals, you can see a lot of the details of these things because the muscles and the skin are so tightly wrapped around the skull. And I think this picture actually demonstrates this really well, because in addition to the tyrannosaurs, in addition to the more unfamiliar creatures in this scene, you also have fossil birds, which haven't been reconstructed in the same way. They've been given a very generous covering of feathers and of muscle and things. So it's kind of funny that, for animals that we're more familiar with, we wouldn't dream of shrink wrapping them, but for fossil animals, that was kind of the norm, at least until relatively recently. For a number of years, paleoartists have been sort of tweaking the way that we reconstruct fossil animals, and there's been a movement away from things like shrink wrapping and from showing animals sort of doing lots of the same thing. There's been an awful lot of stereotypes are present in paleoart. So as I say, people have been tinkering with some new ideas within paleoart for the last few years or so. But last year, back in 2013, we really sort of had the door kicked down on this front. And this was kicked down by a book called All Yesterdays, which is inspired, I guess, or given a name, I suppose we should say, to this movement in paleoart. This has been trying to move us away from some of the peculiarities, some of the odder ways that we reconstruct fossil animals. So for things like shrink wrapping, things like All Yesterdays really demonstrated how silly shrink wrapping was. And they did this by showing modern animals reconstructed as we would those of as we would reconstruct fossil animals. And you can see on the screen here some examples of how ridiculous some of these forms look. So moving from the top left, we have a baboon. On the top right, we have a reconstruction of a cow. The bottom right, we have a couple of swans, and the bottom left, we have a reconstruction of a cat. Now, there's various other reasons which might explain why we have some rather peculiar appearances to these animals, but what I want us to emphasise here is this shrink-wrapping approach, this really tight adherence of the muscle and skin to the underlying skeletal contours, and they look nothing like the modern animals. And when we take this approach to paleontology, what it would suggest to us is that we need to move away from the reconstruction you see on the left-hand side of the screen here of these sort of really almost kind of deathly looking animals. These are sort of like zombie dinosaurs, where we can see every single bulge and every contour of the musculoskeletal system, and we move towards something more like the animals on the right, where we can't see this, where there's lots of soft tissue. There's a very generous coating of muscles and a generous coating of other soft tissues, of fat and feathers and fur and all this kind of thing. And the resultant animals are far more realistic to look at than the sort of more traditional approach that we've had in paleoart. And so All Yesterdays, as I say, is really sort of, I don't think we could say that it started this movement, but it certainly has given a name to it, and it is kind of put words to a lot of the tropes and a lot of the stereotypes we have within paleoart. And I think you know, all yesterday has had a very positive influence in Paleoart. I think it's really helped us move towards producing a much more convincing views of deep time. Okay, so that's soft tissues. How about colour? Okay, so this is something that any paleoartist gets asked this all the time. How do you know that you've done the colours correctly? Well, the answer is that 99% of the time we don't. And you know what? We don't really care that much. We'll get to that in just a moment. We can deduce the colour of some extinct species sometimes in rather simple ways. Sometimes, for more recently extinct animals, we have the we still have the bits of their fur and bits of their pelt preserved, and we can just look at it and go, well, it's orange, and that can tell us something about the colour of these extinct animals. So you've got ground sloth fur, for instance, on the bottom left-hand side of the screen there, which kind of tells us that these animals must have had a kind of gingery brown fur in life. We can use other mechanisms for recently extinct animals. You see some cave art in the bottom right-hand portion of the screen there. This is cave art of Coelodonta, the woolly rhinoceros, and you can see there's a couple of reconstructions of it there. Well, not reconstructions, these were drawn from life. They weren't reconstructions at all. See a couple of images of Coelodonta on the screen there, and you see that both of them have this kind of black band running down the middle of the animal. Probably tells us, as these animals were being drawn by people who were seeing them in their day-to-day lives, it tells us that they probably had these kind of darkish bands running down the middle of the animal. So that's pretty cool. We can actually sort of, I guess, plagiarise the artwork of our ancestors to give us some information about the life appearance of these animals. Of course, there are more sophisticated ways of determining the colours of fossil animals as well, and these involve looking at pigment cells, otherwise known as melanosomes. We can look at the pigment cells that are preserved in fossil feathers and in fossil skin, compare them with those of modern animals to get some idea of the colour correlation. So the way pigment cells are arranged, their density, their sort of their structure, their arrangement to each other, these all equate to different pigmentation on animal skin and animal feathers. And so by sort of comparing the fossil ones with those in modern animals, where we know what pigments they produce, we can get some idea about the colours of fossil animals. And of course this has been done for a number of animals, including several dinosaurs, like things like Sinosauropteryx and Hawkins, things like Microraptor. In more recent years, we've moved away from just Mesozoic dinosaurs. We started looking at marine reptiles. We started looking at things like giant fossil penguins, and this all seemed really cool. We're picking up information on the colour of animals that have been extinct in some cases for tens of millions of years. And this is something we've kind of never thought we'd be able to do. This is proper through the looking glass stuff. Unfortunately, a lot of the science behind these colour restorations isn't quite as tight as we might like it to be. And in fact, I think we could say that really there's some dark clouds that have been cast over colour restoration from melanosomes. And there's several different reasons for this. Firstly, we know from at least modern birds that feather colour is only partially determined by pigments. There's also what we call structural colour, the way the light refracts on feathers, the way it reflects off it. The arrangement of the feathers themselves can influence the colour of these animals, and it's actually a combination of the structural colour and the pigments which produces the colour that we see on these feathers. So of course for lots of feathered dinosaurs we have to wonder, was that the same thing? Fossilization can also alter the way that the melanosomes are arranged. And this doesn't just apply for feathers, this applies to skin as well. The high pressures and the high temperatures can alter the relationships of melanosomes to each other, and it makes us question whether or not we're actually seeing the original composition of those melanosomes, or whether they've been altered through the fossilization process. In some cases we can really struggle to tell melanosomes apart from bacterial films. Okay, so of course we get fossil bacteria in the same way that we get fossil, everything else. If you're getting soft tissues preserved, there's no reason why there shouldn't be bacteria preserved as well. And sometimes it can be very difficult to determine which parts of the soft tissues on animals are bacteria that were decaying those animals, and what is actually melanosomes that were originally present on the feathers. We also have extremely small sample sizes of these animals. So this is science. We want to be able to compare the colours of these animals across multiple specimens. We don't just want to be looking at one of them and saying yes, we have the answer. We need the basic tenets of science is being able to repeat that experiment and seeing, do we get the same signal again and again? And in some cases we just don't have the fossils to do that. So there's lots of reasons, there's actually more than I've just gone through here, there's lots of reasons why we might want to question some of these soft tissue reconstructions of extinct animals, and indeed, at least my take on it is that I don't think we can really reconstruct the the appearance, the coloration I should say, of these fossil species that reliably. I think once we get beyond a certain a time limit, if you like, where we don't get the actual colours preserved in more recently extinct animals, I just don't know that we can determine the colour that accurately, at least for the minute. And I hope to be proved wrong. It'd be nice to be proved wrong in the future, but I think there's just too many caveats to these colour restorations based on melanosome. Once we have determined something about our colour of these animals, we can then start thinking about what environment to put these creatures in. And this is at this point that we turn away from the direct fossils themselves and start looking at the sediments they were preserved in, because the sediments are indicative of the environments where at very least these animals were buried, where their carcasses were finally laid to rest. And of course the sediments don't just tell us something about the environment of where these animals died and were transported to, they tell us something about the paleoclimate, how warm it was, something about the weather. If the animal has not been transported too far from where it died, and there are various ways we can investigate this, if the animal has more or less died where it was living, that might tell us an awful lot about the local geography and the actual local environment itself, about the topography, about the sort of landscape. Was it very dry, or was it covered with rivers and this kind of thing? So we need to remember that it is not just about the fossils; it's also about the sediments themselves. And we can actually produce some very detailed sort of models for the local environment as where these animals were living, and of course we can use that to inform our reconstruction. We make sure that our animals are put in as accurate a setting as as we can. And of course, what we need to make sure that this sort of marries up with is that our animal is sort of shown living in the right kind of environment. So we need to remember, as I say, that animals don't always die in the place where they lived. And so if we find, like an ankylosaur, for instance, out in the middle of an ancient seaway, we can probably be fairly confident, just based on the adaptations of that animal, that it didn't die there, that it was transported out there, by floods and by rain and this kind of thing. So we need to make sure that everything sort of marries up. And that's not to say that we shouldn't draw animals in unusual places, because animals do end up in unusual places which they're not necessarily adapted for living in. But we just need to make sure that we show our animals in places that they that kind of is in keeping with them. They're not shown doing outrageous things in outrageous places where they wouldn't be able to do them. There's a lot more that we can tell from sediments that sort of might also inform our reconstructions. So it isn't just about the environment. In some cases, we might want to have a look at the trace fossils that some animals may be associated with. So trace fossils are things like trackways and burrows, the records of animals when they were alive, not just their bare bones. In some cases, we find really interesting trace fossils. So things like dinosaur burrows. We find dinosaur remains actually preserved inside burrows, which, from their functional morphology, we've actually inferred them to be making themselves. So sediments aren't just about sort of the broad scale environment. They can tell us a little bit about the microenvironment, and sometimes even about the behaviour of the fossil animals that we're trying to reconstruct. Of course, the local setting that our animals are living in, 9 times out of 10, if we're drawing a sort of a terrestrial scene, it isn't just going to be a sort of a barren environment, sort of a desert-like place. It's also going to have an awful lot of plant life. And there's a lot we could say about looking to fossil floras to reconstruct them accurately. We do a whole talk on that. We're not going to go into that now. We just don't have the time to do that. But what we can certainly say is that we use as much data as we can from paleobotany to inform us for the nature of our the nature of the plants that were around at the time with whatever animal it is that we're trying to reconstruct. And there are lots of difficulties with this. As I say, there's a lot we could say about it. I'm not going to going to kind of glaze over it here, but as I say, these plants to give us the best impression we can of the plants at that time. And it's only then, okay, so we've only just finished doing all of our research, it's only then that we can really start to put our images together and start to think about things like the composition and the exactly what we want going on in our scene. All of this research goes into producing a relatively simple painting, a relatively simple sculpture of these animals, and obviously the more complicated our images are, well, the more research that has to go into it. The bottom line is that Paleoart really is not just a case of picking up a pencil and drawing these things just however we imagine they may have been. There is so much more that goes into it than that, and it is no surprise whatsoever that the best paleoartists are also those who are sort of most versed in the science and who put the most effort into the initial research behind their paintings or behind their sculptures, behind whatever they're doing, before they start actually executing their artwork. And so that pretty much brings us to the end of this presentation. As I said, this is really just the tip of the iceberg. Okay, so if you want to continue to know more about Paleoart and things, there's actually sort of a growing body of literature on Paleoart. So there's lots of suggested reading on the screen here. I guess I should have my own book, which okay, it's not about Paleoart in the strictly. Obviously, it's about pterosaurs, it's about flying reptiles, but there's lots of stuff in there that is quite relevant to the Paleoart of pterosaurs. Some bits of it, particularly the soft tissue chapter, were almost written with artists in mind. Lots of things about musculature and about the life appearance of these things, which which might be of interest to paleoartists. Me, I guess, to say a few thanks to people. As I said at the start of the talk, this was all done in association with the Fossil Festival, so I want to thank the organisers of the Lyme Regis Fossil Festival this year for having me come visit. I want to thank the University of Portsmouth because they actually paid for the art gallery that I put up in Lyme Regis for the week, so they kind of they were quite important for getting me there, and just a number of other people who deserve thanks for helping sort of get this talk and get the gallery underway. And of course, thanks very much to you for listening. If you like what you've just heard and you'd like to hear more stuff like this, then please let me know. Either leave a comment here or leave a comment on my blog. Yeah, we'll see how this plays out. Okay, so thanks for listening, and yeah, maybe we'll do this again sometime.